Hello, Honors Chemistry, and welcome to Section 2.9, where we take everything, there's really nothing new in Section 2.9. We're just going to take all the conversions we've already talked about and talk about how they're a smidge different if we're talking about 2D and 3D measurements, right? So when we're talking about 2 dimensions, right, we're talking about things like area, right? 3-dimension would be things like volumes, okay? And if we think back, right, you guys have known for quite some time now that area can be measured in things like meters squared or any variation on length squared. Volumes would be cubed and any variation of length cubed, right? And if we think about what that means, right, so if I have a length, right, so let's say that this is 1 meter, right? That is a length. It's a one-dimensional piece of information. Now, if I were going to take that and turn it into this, right, such that it was 1 meter by 1 meter, now I can do an area, right, where my area would be 1 meter times 1 meter, which gives us 1 meter squared, yes, because that's where that squared comes from, because I have meter times meter, which gives me meter squared. 1 times 1 happens to still be 1, yes? But let's say as a point of reference, now we are going to talk about centimeters. This is equal to 100 centimeters. This is also equal to 100 centimeters. So if I wanted to do this area in centimeters, it would be 100 centimeters times 100 centimeters, which is equal to what? Right, 10 to the 4th centimeters squared, right? So centimeters, right? And 10 to the 4th comes from the fact that we would have 4 zeros if we put all that together, right? So it is not true that 1 meter is equal to 100, or 1 meter squared is equal to 100 centimeters squared, right? Because that doesn't take into account the fact that we are taking these two quantities and multiplying them by each other, or squaring them, right? So this is not true. 1 meter squared is equal to 10 to the 4th centimeters squared, because we have to square not just the conversion, not just the unit, but the entire measurement, right? The entire relationship. So if we take this and we were to square the whole thing, that's how we come up with this. Yes? Does that make sense? All right, let's go ahead and apply this to a couple of scenarios to help cement the point. So an automobile engine has a displacement of this many inches cubed, right? So that's a volume. What is its displacement in cubic centimeters? So we would like to go from this, which is inches cubed, to so many centimeters cubed, okay? So first, do we know a relationship between inches and centimeters in one dimension? Yes, we do, because you've memorized it, right? 1 inch is equal to 2.54 centimeters. Now, if I want to turn this into 3 dimensions, I have to cube each of these. Yes? And that is the conversion factor we're going to use. So then this becomes 289.7 inches cubed. And then we're going to put my inches cubed down here. So 1 inch cubed, 2.54 centimeters cubed. Now, the reason these are different, and maybe we'd be better off doing that, right, is because 1 cubed is still 1, right? And depending on how you do your math, right, if you are likely to forget to apply that 3, right, then go ahead and do that math, like what is 2.54 cubed, and plug that number in, right? But then what's going to happen here is that my inches cubed will cancel, centimeters cubed is all that's left. I just have to remember to cube that 2.54, so 2.54 cubed, then multiply that by 289.7, right? And then that's going to give us 4747.33 centimeters cubed, right? And then we're going to round it to 4 sig figs, so 47 centimeters cubed is the displacement in centimeters cubed, right? Which makes sense that it's a larger numerical value, right? Because centimeters are smaller than inches, right? Okay, how many cubic inches, right? So how many inches cubed are there in this many yards cubed, right? So again, going back to life things we should know, right? 1 yard is equal to, right, 3 feet. Now, if I am going to talk about this in 3 dimensions, I'm going to have to cube each of these conversion factors, yes? So, starting with my given, 3.25 yards cubed. Now, 1 yard, 3 feet, cube each of those, right? And now I would be at feet, but then I have to get from feet to inches, so 1 foot is equal to 12 inches, cube each of these, 1 foot, 12 inches, right? So now yards cubed cancel, feet cubed cancel. Now I just have to do the math, and again, remembering to apply that cube to the 3 and to the 12, right? And the reason this always looks confusing, right, is because 1s to any power are still 1, so sometimes our mind just, just doesn't like looking at what it looks like, but that's what it looks like. And so now we're going to round this to 3 sig figs, right? So 152,000 inches cubed, right? Because again, right, if I stopped at 152 inches cubed, right, that's the right number of significant figures, but it's not the right sized value, yes? And don't forget, you could always express this as scientific notation if you prefer. So 152 times 10 to the 5th inches cubed would also be a correct representation with the right number of sig figs, right, if that's what you prefer. All right. Thank you for listening. Be good. And in the next one, we talk about density from the perspective of using it as a conversion factor. All right. Thanks for listening. Be good. See you soon. Bye.